So in this video we're going to look at the effect of temperature on Kc, but the first thing we need to draw our attention to is that nothing else except temperature can affect Kc. The only thing that can affect constants in chemistry is temperature. You've got to remember that. The only thing that can affect a constant in chemistry is temperature. So adding a catalyst won't change the value of Kc. Changing the concentration doesn't change the value of Kc. Changing the pressure is irrelevant because it's about concentrations, Kc, but it wouldn't affect Kc. Only temperature does. Now, we can go into a little bit more detail of why, but that is not on the syllabus. You do just need to know that only temperature can affect Kc. And they will ask a lot of questions on this. They'll lead you down the garden path to try to get you to say that changing the concentration does affect it by asking you lots of questions like asking you it'll shift right, then it'll shift left, then this will make it shift right, and that will make it shift left, and then what effect will that have on Kc? And you'll automatically want to say, because it shifted, it had an effect, but it didn't. Only temperature can have an effect. What we need to do is remember this sort of curve that we looked at right back at the beginning. This is an equilibrium where equilibrium is reached here. Position of equilibrium is to the right. I've got more products than I have reactants. And our Kc is a value that takes into account the ratio, the fraction between these products and reactants. Now, what happens when I increase the amount of a reactant? Well, we were at equilibrium and we're going along at equilibrium, so let's just move these out of the way for a minute. We're going along at equilibrium and all of a sudden I add some more reactants. I didn't do anything to the product, so they keep trundling along. And then those reactants will need to decrease over time. And so they'll decrease. But how did they decrease? Well, they converted some things into products. So the whole position of equilibrium has shifted closer to the product side. We've moved up, which is where the products were, so we've shifted to the right, but our fraction, our ratio between the two has stayed the same, because when we added our reactants, they had to convert into products and reach a new position of equilibrium. So we're not talking about instantly what happened to the Kc, we're talking about when equilibrium was re-established, there was no difference. Now that's quite complex, which is why the exam board don't expect you to explain it. They just expect you to know that only temperature affects the value of Kc. So only temperature can affect Kc. Just don't fall into the trap. So how does temperature affect Kc? So what do we do when we've got one of these? The first thing we do is we look at that and we see that that is exo. So our reaction gets hotter in this direction, which is bad colouring, isn't it? We should have done that in red because it makes sense for it hotter to be like that. So let's do that. Gets hotter. And in the reverse direction then, it must get colder. So unlike when we change concentration, this is like an external factor. This is just going to shift our position now. So the forward reaction is, remember that's the first statement we have to make, the forward reaction is exothermic. So increasing the temperature, when we heat it up, we're not going to go forwards because according to Le Chatelier's principle we need to cool down. So it's going to favour the reverse, the endothermic reaction. Cooling down direction, so the equilibrium is going to shift left to oppose the change and absorb the heat. And the concentrations therefore of our reactants will increase because we've shifted left and made more reactants, and the concentrations of the products will decrease. So remembering that Kc is concentration of products over reactants, what's going to happen to the value of Kc? It must decrease because we've got more bottom line and less top line. So we've got a smaller number on top and a bigger number on bottom. That makes a smaller fraction. Why don't you see if you can apply that information to this example? how did you get on? Did you get that? Right. One more to have a go at. So again, pause the video and have a go. So did you fall into the trap? Unlike the other two examples, we were decreasing the temperature here. So take a look at your answer, take a look at my answer, and see if you managed to get that one correct.